All right, and we're recording. Hi again, Karima. So today I just want to go through some of the topics and exercises that we need to do for today and tomorrow. And then tomorrow I'm going to work on tomorrow's and Wednesdays, and then Wednesday, Thursday, Friday, I'm going to do on Thursday, I'll do the work for Wednesday, Thursday. And then Friday, the only work you have to do is a Kahoot that's about all this stuff that we're doing, and do your Alex topics. You should check Google Classroom. There's a document up there that has the number of topics you have to do to bring your grade up. So I think you've been doing all right, Karima, but a lot of students are way behind. So although I've assigned specifically for Alex topics, everyone else, y'all need to do many more to catch up. So just go on that document and you can see how much you need. So this week we are continuing our work on scatter plots. And on Monday and Tuesday, we're supposed to be learning about the best fit lines, which we had done a Desmos exercise about last week. We're going to do a little bit more on Desmos exercises, not Desmos, on best fit lines and scatter plots. And then tomorrow and today, we're going to be introducing a concept called the correlation coefficient. So, Karima, were you able to see the do nows and the questions of the day in Google Classroom? Was that a problem?
Yeah, I did have like a little problem getting to it.
You had a problem getting to it? All right. So if you go to Google Classroom, which you should just do by going to classroom.google.com, you should be signed up already. You go into your intermediate algebra one. And today's due now, and you know what? I'll just bring it up here. I'll just do it this way. Go to classroom, google.com, and you're in fourth block. And then, so if you go to classwork, that's where you're going to find everything you need to do if you go to classwork. And then this is the one that was due yesterday. So there are 4 different graphs here. And I'm going to view the question. And there's, here it is. If you go to the question, there are 4 different graphs here. And which line is the best fit for the graph and why? So I'm just going to click on this link so you can see which it is. These same pictures are here on the slides as well. So we'll just go through these one by one really quick. So in, we have a scatter plot here. We got 4 different scatter plots. And those are going to be the relationship between 2 variables. In this case, it's wins and number of runs allowed per the game, right? So this means like how many games a team won, and this is how many runs they allow. So I assume this is baseball that they're talking about. And what it shows very clearly is that as the number of runs allowed per game goes up, your number of wins is less, right? Now, looking at this, this is probably the data from the season of a team or from a league. Which of these 2 lines, the solid line or the dashed line, best represents this graph?
The solid line.
Yeah, the solid line, definitely, right? It's the relationship is pretty much going down, and so this solid line is going down, whereas this dashed line is going up. So that one's pretty clear. All right. Now, how about for this scatter plot here? Which line do you think better represents what is going on in the relationship between the average score in the surveys and the amount that someone spends on the dinner?
Uh,
Solid line or the dash line? Which one do you think?
I'll say both. But they both look like it can represent it the
They
same.
both do, but one, right? So they both are going up at kind of the same slope. That's true. So the question in deciding which one is a better line is which line is closer to more dots?
The solid line.
Yeah, I would say the solid line. So even though they have the same slope and they both, I think you're correct, they both, map this relationship pretty well. The solid line is closer to more of the dots. They have the same slope, but this one is kind of in between. This one, this dash line is only close to the ones at the top. Um, so that's clear. Then we go to this one. Um, the price of crude oil, which is how much it costs to make gasoline, and then the cost at the local gas station, right? And so obviously, as the price of oil goes up, the cost of our gas at the gas station goes up. Which one, which line do you think is better in this case, the solid line or the dashed line?
The dash line.
The dashed line. And why did you say that?
Because like if you like when you look at it, it's like the dots are more following the dash line than a solid line.
Yes, exactly. The dots are much closer to this dash line than the blue line. The solid blue line, right? It's below all these dots and it's above all the dots here. So it's kind of the slope is a little bit off. So this dash line is a pretty good fit for these dots. And then finally, how about here?
The dotted line.
Yep, the dotted line again, right? Again, in this case, the blue line is kind of below where it's supposed to be. What they did here with this blue line, how they created this blue line, instead of finding a line that fits most of the dots, what they did was they just took the first dot and the last dot and they connected them and said that's the fit. But although that takes you from the first to the last spot, it doesn't really take into account that most of these dots are kind of above that, and this low dot is a little bit off compared to the general trend of what's happening here. So this is kind of our best fit line, and in order to do this exercise, all you had to do was go into your Google Classroom, go to that question that was for yesterday, and then you would answer it in there. See, some of the students have already done it. All right, Antoine's getting to work. All right, so you go in there and you answer those questions, and that will give you credit for that. Is that clear on how to get there?
Uh huh.
So you just go to your Google Classroom, enter it, and then I will, grade those later this week. So that, is all about best fits. And so one of the things that's important is that here they're giving us the line for the scatter plot. And we can use technology to actually really well to create that best fit line. So the line that, you remember last week we were using that Desmos to find a line and get it in the green. Technology can actually help us do that. If we were in school, I would show you how to do this on those calculators. Since we're not, I'm going to kind of show you how to do this on GeoGebra. And this is going to help being able to use this spreadsheet is going to be able to help you do today's exit ticket, which is on Algebra Nation, because the Algebra Nation is actually asking you to use some technology to help you. And so using this GeoGebra spreadsheet will be really helpful in doing that. In this case, what you're going to want to do for the exit ticket is click on this GeoGebra classic hashtag spreadsheet. That'll give you, when you click on it, that's going to give you this. Well, eventually, yep, there it is. It's going to give you this, which allows you to plug in numbers here and then do it. I'm going to show you one that I've already created. So in this case, we have a relationship with the x variable being the pounds of ice cream at a ice cream store that they sell. And then what's the y variable?
The set, the degrees.
Yeah, so the temperature in Celsius. They basically everywhere else in the world except the United States, they measure temperature in Celsius. We're a little bit special, so we use degrees and Fahrenheit. But so this is just temperature. The higher it is, the hotter it is. And so I plotted this on a I took all of those plots. So what you would do is you put these, how you would figure out what the line of best fit is that you're going to put all of the x variables in one column right here, and then all of your y variables in another column. And then, so then you would highlight it like this. And then you'd click on this button right here, and then you'd go to variable analysis, and it would plot it like this. It would give you a scatter plot. And so this is the scatter plot. So you can see, right? So point 20 and 6, that's this point right here. And then 18 and 4.5 is here. And then there was also an 18 and 5. So all of these points represent what was there. And so all you need to do actually to find the line of best fit is you come in this GeoGebra and you go to down here at the bottom where it says regression model. You see that where I'm pointing? You do that and you click linear and it gives you the best fit line. So this line, the calculator has figured out that this is the line that maps the relationship between the temperature and the amount of ice cream sold, and puts it right here. And so, and then this is the equation of that line. And so if you were given another x value, another temperature, you could plug it in here. If you plug it into this equation, it would predict, it would show you somewhere on the line where it would be. So if I said, if x is 19, what do we think y would be? It would be somewhere around here. It might not be exactly there, but that's what we would predict it to be. And so that's how we use this line of best fit. And this is one way to use technology to do that. And so today's check for understanding is Algebra Nation Section 9, Topic 1. So when you get off the call today, what I would suggest you doing is, hold on, if you haven't done it already, go to Algebra Nation, and you would probably log on there through Clever. That'll get you there faster. You log on to Algebra Nation. Seems to be taking its time. And you go to videos and more. You scroll down here all the way to topic 9, 2 variable statistics, and watch the video and scatter plots and follow along in your Algebra Nation book if you have it. So these videos are really good. I actually watch them. They're much better than some of the other topics. They're really helpful in understanding best fit lines. So you do that. Then what you're going to want to do is come here and do this check for understanding. And so what this is saying, Karima, is using a graphing utility, make a scatter plot of the data in the table, approximately what kind of relationship does the data display. So what you're going to want to do is, have this information. You're going to want to come to a spreadsheet here and just, put all of the X's here like this. And then what were the Y's? Where do we go? The Y's are 0.75, 1, and 1.5. You're going to do 0.75, and then 1, and then 1.5. And then what were the others? 0.75, 1, 1.15, and a 1. 1.15 and 1. Now, I'm not going to do all the data just because I'm just showing you how you would basically do this. So what you do is you'd highlight this data like this. You'd take your mouse, after you go to that GeoGebra classic.spreadsheet link, you'd go here like this. You do this, and you go to 2-variable regression analysis. And it's going to plot your points like this. And after you've plotted all of the points, you'll either see your question is going to be whether it's a linear, exponential, or quadratic. And linear means it's going to be a line. It's going to look like a line. What is an exponential function going to look like if the relationship is exponential?
It's a thing.
It's a thing. It would be going up really fast, going up or down really fast. Like the graphs of the COVID-19, it'd be going up or down really fast. And a quadratic would be, what is a quadratic look like? Parabola, exactly. It's going to be a U that's going up and down or down to up like that. And so after you plot this data, you're going to see what kind of relationship is there. Then you answer this question, which is easy. What kind of relationship do we see here? Linear, exponential, or quadratic? And then finally, you're going to have this question that you're going to pick a couple of answers. So that is yesterday's work and exit ticket. And then today I want to introduce the concept of the correlation coefficient. So if you go to this week's slides, there is a long explanation about what correlation coefficient means and how it works. And what I would suggest again is go and watching this video, the topic 5 in section 9, and then the work is going to be checked for understanding, because that video does a really good job of explaining the concept of a correlation coefficient. But basically, the correlation coefficient for a linear best fit line or a linear scatter plot tells us whether the relationship between the two variables, the x and y's, it tells us two things. One, if it's positive or negative, like is it going up or is it going down? And two, is the relationship really strong and close to a line, or is it not really close to a linear relationship? And so in this case, you can see that are the dots here, is this a positive or a negative relationship? Oops. Can you see the dots that I'm pointing at here? Guess not. In any case, this is a negative relationship right here. All the dots are going down. And what we can see is that you could actually draw a line that connects all these dots. This is a, you can connect all of these dots in a line. And so therefore it's a -1. So the correlation coefficient here is between -1 and 1. And if it's a 1 or a -1, it basically means it's a straight line. So here we've got a -1. This is a straight line going down. And here it's a +1, which is a straight line going up. Now the rest of these are somewhere between a line going down and a line going up. Here, this is pretty strong. This looks like, if I look at this, I could say, hey, this is generally going down. So this has got a strong, pretty strong negative correlation. This has got less of a strong negative correlation, but it still could maybe be looked at as negative. This one, I don't know. It's kind of maybe going up, maybe going down, but this number is really small, 0.02. This one is slightly more positive. Yep. And this one, if I stop moving around. And this one is a +1. So again, so this concept is, when you look at a scatter plot, you want to know whether it's strongly negative, whether it's really close to being a line or not. And so that's like how well does the equation of a line map the relationship between these two variables? And that's what the correlation coefficient answers. And so again, go to Algebra Nation, do this, do the check for understanding, and that will be the work for today. And then tomorrow we've got some Khan Academy on the same concept. So today's lesson and tomorrow's lesson on correlation coefficients go together. What you're going to want to do is, this is going to be the work for tomorrow. So one little hint, some people were having trouble doing this. Some people had already jumped on and worked on this correlation coefficient. What you're going to want to do is move. How you do it is you move this up, and this correlation coefficient up and down to match the scatter plot that you see here. So if I look at these scatter plots, I got A, B, C, and D. Now, if I look at scatter plot A, is that a positive relationship or a negative relationship? Like if I were going to draw a best fit line, would that be going positive or would that be going up or down?
Down.
Yeah, down. So that's a negative. So that means for scatter plot A, it's one of these two. It's -0.4 or -0.93. Does that, now, if I'm looking at all of these scatter plots, which other ones have a negative correlation? A, B,
B.
yeah, go ahead. Which one?
B.
Yeah, B is also really negative. It's kind of like this. And you can see that, and between A and B, so both of these, A and B are both negative. Between A and B, which one is a line, more appropriate for mapping? Like which one would a line be closer to all of the dots?
B.
B, yeah. So B has got definitely the stronger negative correlation. Like it's closer to -1. This is almost This is like really close to linear relation. So this would be like that, and this one would not be. And then if you look here, so C and D, between C and D, which one do you think a line like has a better linear correlation? C or D?
C.
Yeah, definitely C. And so that means we got to pick the number that's bigger for C, and then you would move it up like that, and that's how you would do this exercise, and you'd kind of do it the same thing 3 or 4 times, and you would be good. So that's tomorrow's exercise that you can do after you go through the 2 exercises in Algebra Nation. Is that clear? And then don't forget to do the do now today's question, which we already walked through. All right. And so that's all I wanted to go through today. And that's it. I'm going to stop recording now.